Yes, good morning everyone. Today we will be discussing how do we evaluate an hypothesis. So hypothesis evaluation we will be discussing today. So friends, if you remember in the last class we have seen the math part, the mathematics behind backpropagation algorithm, and we have seen how to derive the cost function and how weights are being adjusted so that how do we find actually the partial derivatives, right, the gradients in order to update the weights and biases. So it was a little bit complicated though, but it is mandatory that you should understand, right, how this back propagation actually works and how we will minimize the error by calculating the gradients of all the parameters involved in it. So the weights and biases are the parameters involved in it, and we have seen how to calculate partial derivatives with respect to weight, and we have seen how the cost function is used and how cost function will be minimized by using gradients, right? So how weights are being updated, that entire math part we have seen in the last class, that is very important, my dear friends. So I hope you might have gone through that recording of the previous class once again, because if you go through it a couple of times, then only you will become more comfortable in understanding backpropagation algorithm, right? So moving forward, today we will be discussing one important concept called as evaluating hypothesis. Evaluating hypothesis, right? So how do we evaluate a hypothesis? So friends, you know very well what is a hypothesis, right? So let me share the screen. I have shared my screen. So what is a hypothesis? Can you recollect what is a hypothesis? Can you recollect what is a hypothesis? You can respond in the chat box. We have discussed hypothesis in candidate elimination algorithm, find S algorithm, decision tree, right? Hypothesis is nothing but the target function or whatever machine is learning. Yeah, great. A statement that shows the relationship between inputs and outputs. Yes, that is hypothesis. Very good, 572. So, hypothesis is something which shows the relationship between input and output. And what we need is there can be multiple hypotheses that can be formed for a given problem. It's a mathematical function. Excellent. Right. So it's a mathematical function which establishes the relationship between inputs and outputs. So we have seen one hypothesis in finders algorithm. We have seen which is a most specific hypothesis, right? Then in the candidate elimination algorithm, we have seen there is a possibility of multiple hypotheses, right? So we know very well that there can be more than one hypothesis for a given problem. Now, what we want is we want a hypothesis which will best represent our problem, or which will best fit the relationship between input and output. So we want a hypothesis which gives minimum errors, So friends, coming to artificial neural networks also, for example, if I am trying to model a problem, using a neural network, so friends, there can be different ways of constructing or representing that problem using neural networks. So I can start with a two-layer network, or I can have a three-layer network, or I can go for a single layer network only. So for a single problem, I can get multiple neural network models also. So in artificial neural network, what is a hypothesis? The final function which we are getting, a power l, the final a power l, whatever we are getting, that is the hypothesis, right? So you have a hypothesis in every mechanism: finders, candidate elimination algorithm, decision tree. whatever the tree you are constructing at the end, that the decision tree is a hypothesis. The decision tree is a hypothesis because it shows the relationship between output and input. It will tell you for a given problem how we are going to come to a conclusion whether the person is going to play tennis or not, right? So friends, we know very well that hypothesis is a mathematical function. So in find s we have a hypothesis. So we had a hypothesis in find s algorithm, right? In find s we had a hypothesis. If you remember, in find s we were getting only one hypothesis, which is called as most specific hypothesis. It's called as most specific hypothesis. Most specific, that yes represents most specific only. But in candidate elimination we have seen there is a possibility of multiple hypotheses also. So we have seen that in candidate elimination, and in that we try to pick the best possible hypothesis for our problem. So in candidate elimination we have seen the most specific, most generic. So we started with a capital S and capital G, and if you remember we ended up learning multiple hypotheses. So candidate elimination we have seen multiple hypotheses, and in decision trees, the tree, final tree which you are constructing, that decision tree itself is a hypothesis. Similarly, coming to artificial neural networks, if you recollect our yesterday's class, our final output layer, whatever output is coming out of that final layer, which we have represented using AL, right? This AL will be my hypothesis, right? So friends, hypothesis is nothing but a function which represents the relationship between output and inputs. So for a given input, what could be the possible output, the hypothesis can tell. So the point is whether this hypothesis will give correct answer for all inputs or not, right? Generally, it may not be 100% accurate. So what we want is we want a hypothesis which can offer me minimum possible errors. So how do you estimate that error part? That is the cost function which we have seen, right? If you remember in artificial neural networks, it is cost function which will talk about the estimating errors. So we estimate errors using cost function. So we try to minimize our errors. So since the topic is evaluating an hypothesis, I just wanted to recollect what exactly is an hypothesis. So hypothesis is nothing but the target function or a mathematical function which will represent our particular problem our particular problem of machine learning, right? So whether it is a classification problem or a regression problem, right? Whatever may be the type of problem, at the end of the day, when we apply machine learning, we will try to learn a hypothesis, right? So and we try to construct a hypothesis which will solve our machine learning based problems. So now coming back to our topic, so I hope we have we have successfully recollected what is a hypothesis. Now we will go back and we will try to understand what do you mean by evaluating hypothesis. Evaluating hypothesis. So friends, in this particular evaluation part, you will come across one topic called as a central limit theorem. Central limit theorem. Please make a note of this word, central limit theorem. It will most probably come in your external exam also, and it will definitely come in your internal exam. So central limit theorem is very important, my dear friends. So today we will try to understand the concept of evaluating hypothesis. So now what is hypothesis we know, and now we are trying to evaluate a hypothesis. Evaluating a hypothesis means Yes, there is a possibility of getting multiple hypotheses for a single problem or for same problem. Suppose for a problem I have got two hypotheses, H1 and H2. H1 and H2. So now I need to identify, I need to evaluate whether H1 will give me minimum errors or H2 will give me minimum errors, so that I can finally pick either H1 or H2. So this process of identifying or evaluating the hypothesis and finding the most appropriate, most accurate hypothesis, this process is called as evaluating hypothesis. So I hope you understood the meaning of evaluating hypothesis. So is it clear? The meaning is clear to everyone? Why are we evaluating hypothesis? Is it clear? Kindly let me know in the chat box, why are we evaluating hypothesis? So we have multiple possible hypotheses. We need to pick the one which offers minimum errors. Right? So the agenda of the topic is clear, right? So now friends, there are two important words which we need to understand in this process. One is called as sample error and another one is called as true error. Sample error and true error. Please try to understand this. What is a sample error and what is a true error? The true error of hypothesis H with respect to target function and distribution D is the probability that H will misclassify an instance drawn at random according to D. What did you understand by this statement? Did you understand anything? Anybody understood the meaning of this statement? Anybody? What is true error? What is true error? I'll just show it again. True error of a hypothesis H with respect to target function f and distribution D is the probability that H will misclassify an instance drawn at random according to D. Instance drawn at random according to D. Anybody understood anything? No? No issues. So friends, here S represents sample data. S represents sample data. S represents sample data or training data. Sample data is also called as training data. So friends, if you remember in candidate elimination algorithm and even in decision tree also, we have used an example of playing tennis, right? A person will go for playing tennis or not. That will be decided based on some parameters. So do you remember how many records were there in that particular data set? Do you remember this particular data set? It was like this, overcast, right? Temperature, humidity, wind, then finally play tennis. Decision tree algorithm, if you recollect, this was the data set we have used, right? These were the parameters: overcast, temperature, humidity, wind, right, and play tennis. So play tennis depends on these parameters. Do you remember how many records were there in that data set? Do you remember? 14. Excellent. B5 is answering some data, the probability of crossing. Yeah. So there were 14 records. Great. There were 14 records in our training data. So friends, that data set which we have used is our training data. So 14 records, whatever you have rightly recollected. So that is my sample data or my training data. So this is capital S represents training data. But my original data may contain lot of records, right? So capital D represents my overall distribution of data, or you can say complete data, overall distribution of data, or complete data, all records. So overall distribution of data. So it means there can be like 1,000 records, 10,000 records, right? 20,000 records, total data set, entire data set. Right? I have only sample of 14 records, but my whole data set is called as capital D. So capital D represents whole data set, complete data set. Now coming to this point, see the definition. Definition says that probability that H will misclassify an instance drawn at random according to D. So means in my entire data set, not on this 14 records, in my entire data set, let us say there are 1,000 records. Let us say there are 1,000 records. So in these 1,000 records, what is the probability that my model will generate a wrong answer or it misclassifies? Misclassifies means what is the output variable, whether he will go for playing tennis or not. Yes or no is the answer. So if the correct answer is yes, but my model says no, that is misclassification. If the correct answer, original answer is no, but my model says yes, means if it is giving a wrong classification, then it is called as misclassification. So this particular error, see here, this true error is an error of misclassification which is found on my entire data set, not on sample, my dear friends. So what is the probability that it may commit a mistake on my entire data set? That probability is called as true error. True error. Now there is another word called as sample error. Sample error. The sample error of the hypothesis with respect to target function and data sample, name itself says. So it deals with sample data. And here, if you observe, it is not the probability, rather it is the proportion of examples that H misclassifies. H is nothing but our hypothesis. So the meaning of this one is, suppose in my data set, I had 14 records, right? So if you remember, friends, in those 14 records, 9 were positive examples. Means in 9 cases that fellow was going to play tennis. So 9 were positive, 5 were negative. 5 were negative. So out of these 14 examples, let us say my model is working perfectly or it is giving correct outputs only in 10 cases. Out of 14, my model is giving correct answers for only 10. Means this out of 14, only 10 times it is working fine. So the misclassification on sample data, here we are seeing the proportion. Proportion means how many times there is a mismatch, that count I am seeing. So how many times it is giving me a wrong answer? 14 out of 10 times it was giving me correct answer. Means what? How many times it was giving a misclassification? 4 times. So how many times it was giving a misclassification? 4 times. So friends, here if you observe, sample error is always an integer. Sample error is always an integer. It cannot be a fractional value because it is not a probability, it is just a count. So in my sample data, there were 14 records. For 14 records, 9 times there was yes and 5 times there was no. Right? In sample data, we also know the output. Right? For input, what is the output? We already know. Now, when I tested it, tested the same thing on my model. My model was giving correct answers only 10 in 10 cases. In 4 cases, my model was giving wrong answer. So that 4 is called as sample error. That 4 is called as sample error. So friends, sample error will be always a number. Keep this point in mind. It can't be a fraction. Sample error can't be 0.7, 0.8 like that. So sample error will be always a number. Remember this point. Right? Whereas true error is always a probability. True error is always a probability. Right? Now, how well does errors S of H? Errors S of H means hypothesis, S means sample data. How well sample error can estimate a true error? This is an interesting point. So friends, there is a relationship between the sample error and true error. So how well a sample error can estimate, how well a sample error can estimate the true error, this is an important point, and this can also become a question in your examination, whether it is mid-exam or external exam. So this is an important point. So those who are attending the class, please make a note of this one. Right. So moving forward, how well errors of S can estimate. So there is another definition of bias. Bias can also be defined as the difference between, right, this E means capital E means error, right? So whatever difference you are getting between sample error S of H minus error B of H can also be defined as bias. Of course, we know very well what exactly is bias and why we use bias. We know very well. Now, what is interesting is, see here. This is an example, friends. Error hypothesis H misclassifies 12 out of 40 examples. Means this is on training data. It is clearly shown, right? Out of 40 examples, 12 times my hypothesis is giving wrong answer. Means 12 by 40. Remaining 28 times it is correct. 12 times it is failing. So errors S of H 12 by 30, right? So this errors S of H value is 12, but if I want to see the proportion, then I have to divide it 12 by 40, right? 0.30. This is not probability, this is percentage. 0.30 percent times the H is misclassifying. Okay, fine. Sample error is known, but sample error is related to only 40 examples which I have seen in the training data. But my original data may contain 1000 records, 10,000 records, or 1 lakh records. Then how can I estimate the true error? How can I estimate the true error if sample error is given? So friends, that is an interesting point. And same problem, right? Similar problem can be asked in your mid exam also. See here, friends, this is the formula. This is the formula. Please make a note of this one. Please make a note of this one. With approximately 95% probability, the true error can be estimated like this, right? True error lies in this interval. Interval means range. So for true error, this is the possible range, my dear friends. Right? So errors S of h, sample error, you know how to calculate. It is nothing but the number of misclassifications done on the sample data. Out of 40 examples, 12 times there was a misclassification. 12 by 40 is my error S of h, right? So error S of h plus or minus 1.96 into errors S of h into 1 minus errors S of h divided by n. So when I calculate this, please observe there are two components. One is plus, another one is minus. So it will give me an interval. Interval means range, right? So minus x2 plus x. Like that, I will get a range of interval. Something like this, minus 3.52 plus 2.6. Like this I can get an answer. So with approximately 95% probability, true error lies in this interval. So this is an important formula, and this 1.96 is not fixed. It will change. I'll show you, right, why it will change and how it will change. So friends, here please observe there is a requirement that your n should be, number of records should be greater than or equal to 30. Means your main data set, overall data set, your capital D should be greater than or equal to 30. Means if it is less than 30, this formula will not work. It will not give you accurate result, right? Now, if you observe in previous slide, we told with 95% probability, with 95% probability, the error formula is this. Now, instead of 95% probability, with 50% probability, if you want to estimate the interval, then instead of 1.96, you have to substitute 0.67. So with 68%, what is the value? 1.00 or 1. With 80%, with 90%, like that, instead of 95, you can substitute any other percentage of probability, then this value is going to change. This is Zn and its respective values are given in this table. So friends, the true error represents the probability of misclassification on the overall data set, which is very important for everyone to know. Like suppose if I have 10,000 records, on these 10,000 records, what will be the percentage of true error? What will be the percentage of misclassification? If I can calculate that, then I can go for another hypothesis. If H1 is giving me more errors, then I can go for H2. I can compare H1 and H2. If H2's error rate is less, then I will go for H2 instead of H1. Or if H1's error rate is less than H2, then I can go for H1 instead of H2. So if you have multiple hypotheses, how do you select? On what basis you will say H1 is better than H2 or H2 is better than H1? On what basis you will tell? Based on this point, sample error, true error. If you know the sample error, you can apply the formula and you can even estimate the true error. So how do you estimate the true error with the help of sample error? This itself can become one question, right? So we will move on. So when we try to represent this probabilities of these errors, right, generally you will get a binomial distribution, right? Fine. That is not our interest. What we need is we need to understand 3 points. What is true error? What is sample error? Then central limit theorem. This is very important. We can expect this in your exam, right? So what is central limit theorem? What is central limit theorem? So friends, consider a set of independent, identically distributed random variables y1 to yn, all governed by an arbitrary probability distribution with mean mu and finite variance sigma square. So you know what is a sigma here, right? In probability and distribution, this sigma represents standard deviation, right? I hope you know what is a standard deviation. So friends, this is standard deviation, right? Standard deviation. SD represents standard deviation. So variance is nothing but square of SD, right? Sorry. Standard deviation is this one. Square root of the same is variance. Right. Now let us try to understand central limit theorem. Central limit theorem. Consider a set of independent variables y1 to yn. Just like our playing tennis example, we had 4 variables: overcast, temperature, humidity, wind. They are all independent variables: wind, humidity, temperature, overcast. Playing tennis, right? Whether this fellow will play tennis or not, that depends on these 4 variables. So this is the dependent variable, right? This is the dependent variable. These 4 are independent variables, right? Now, what central limit theorem says is, consider these 4 variables governed by an arbitrarily probability distribution with mean mu and finite variance sigma square, right? Define the sample mean, right? Mean is nothing but average, right? Mean is nothing but 1 by n, sigma of I is equal to n yi, right? So we are trying to take average on every parameter, every independent variable. You have to compute the average, right? Which is y dash. Now what central limit theorem says is, as n tends to infinity, means as the value of n is increasing, as the value of n is growing, the distribution governing y dash approaches a normal distribution with mean mu and variance sigma square by n, right? So what central limit theorem says? Central limit theorem says, as n approaches to infinity, as n approaches to infinity, right? The distribution governing this y dash is nothing but the mean, right? It will approach a normal distribution with mean mu and variance sigma square by n. Means definitely it should look like this, normal distribution, right? I hope you know what is a normal distribution. Normal distribution means continuously there will be a increase at up to certain point, then from there will be a continuous decrease, right? So this is called as normal distribution. Of course, I'm not able to draw it properly, right? So what central limit theorem says is, as the value of n continues to grow, the distribution governing this y dash approaches a normal distribution. This is what is central limit theorem. So what do you mean by this central limit theorem? As the value of n increases, as the size of your data increases, as the number of records in your data set increases, right, there is a possibility of seeing a normal distribution with respect to your independent variables. Means you will see some sort of stability will come only when you have enough data, enough data. So if you have very less amount of data, right, it will be very difficult to identify, or it will be very difficult to study the influence of these independent variables on our final outcome variable. So as the data increases, as the training increases, obviously the model's performance will improve. This we are studying right from the beginning, right? So if you give more amount of data, more amount of training, right, then obviously you will expect a normal distribution curve like this. So this is what is central limit theorem, right? So as the n value approaches to infinity, distribution governing y dash. What is y dash? Y dash is nothing but this is y dash. Sigma of 1 by n I equal to 1 to n y dash. What is yi? What is yi? What is yi? It is my first parameter, second parameter, like that. On every parameter, right? Parameter 1, parameter 2, parameter 3, I am trying to find the mean, right? I am trying to find the mean of every parameter. That mean is called as y dash, and it will reach to a normal distribution when the number of records or the size of the data gets increased. So this is a central limit theorem, my dear friends. So there are three important points which we have studied today. Point number one is, what is a sample true error? What do you mean by sample error? If you know sample error, can you estimate true error? That is one point. Yes, if you know sample error, true error can be computed. Further, there is a formula. We cannot tell what will be the exact true error, but we can tell the range of true error. True error can lie between so and so value to so and so value. Its interval can be computed by using certain formula which we have seen just now. And the third important point which we have seen is central limit theorem, right? So friends, now there is one important point called as comparing. We will wind up in another 5 10 minutes. Comparing learning algorithms. So what do you mean by comparing learning algorithms? For a given problem, for a given problem, we can have multiple hypothesis. Hypothesis means multiple solutions can exist. For example, H1 and H2 are two problems. So sorry, two solutions or two hypotheses for a given problem. Now, how do you compare them? Now, the problem is I need to select which one is good. H1 is better than H2, or H2 is better than H1. So how do I compare these learning algorithms? How do I compare these learning algorithms? Based on the previous discussion, based on the topic which we have discussed right now, can you compare the learning algorithms? Can you tell how do we compare learning algorithms? Because now you know how to evaluate a hypothesis. So when you know how to evaluate a hypothesis, based on this hypothesis, learning algorithms are nothing but my hypothesis. H1, H2 is my final output, right? So H1, maybe I got H1 from one type of neural network. I got H2, which is also a solution for the same problem, but I got it from a different type of neural network, right? Or H1 is one type of decision tree, H2 I got from another type of decision tree. So you tell me, can I compare H1 and H2? Can I identify whether H1 is good or H2 is better? Can I do it? Please respond in the chat box. Is it possible? Is it possible? Yeah, true error and sample error. Okay, what I will do with true error and sample error? Sample error will be same. See, will there be same sample error for H1 and H2? Sample error will be same for H1 and H2. Need not be, right? Sample error need not be same for H1 and H2. Maybe the data set is same, but H1 uses a different type of neural network. H2 H2 uses a different type of neural network. So sample error itself can be different. We calculate true error and sample error for the hypothesis, which has the less error. We go for that hypothesis. Yes, so we calculate the true error. So first step one. So what is step one? Calculate sample error for H1 and H2. Step 2, calculate true error based on sample error of H1 and H2. Compare the true error and pick the one which offers less, the one which offers less error. Right? So comparing learning algorithms is very simple, right? If you can identify what is a sample error, what is a true error, and if you can estimate the true errors, and then based on the true error value, or based on the fact that the hypothesis which gives you less number of errors, or the hypothesis whose error rate is very less, that hypothesis will be selected, right? So this is what is evaluating hypothesis, my dear friends. So is it clear? Is it clear to everyone? Please let me know in the chat box. So central limit theorem, error, true error, estimating true error based on sample error, these things will come in your mid exam. Okay, right? So